Hello and welcome to my training session on electrical energy metering. My name is Alpesh Popat and I'm electrical engineer. Energy is vital part of our daily lives, especially electrical energy you are all familiar with. Any type of industry, whether it is a telecom or steel or cement, building, transportation, everywhere we see that electrical energy is a input raw material. Majority of industries heavily depending on electrical energy because 60% of their cost goes to the electrical side, and that is why to maintain the overall electrical energy is a decision making factor for them into their business and in the competition. And that is why every company is running energy management programs. So any engineer, if he wants to run energy management programs, he has to know that what is the energy and how to measure and how to meter the energy as well as how to monitor the energy. If you overall understand this broad concept in detail, then you can deal and you can handle any type of energy management program in any type of industry. In today's discussion, we will be discussing on power circuit diagram. We will be talking on basic SLD, which is a single line diagram, and three-phase power wiring diagram, especially for the metering system. We have a separate training module on detailed power and schematic diagram for LT panel as well as the AMF of the generators. Wiring diagram of any type of energy meter, whether you have an energy meter of LNT or Fluke or Conserve or Enercon, their basic wiring diagram is same all across worldwide. So if you basically understand that how the wiring comes from the primary side and how to connect onto the meter and where to connect and why to connect, if these basic things if you are understanding properly, then I think you can understand overall concept of the metering and you can even troubleshoot also. In the wiring part, we will be discussing on voltage sensing, current sensing, CT shorting methods, communication wiring. Next is a parameter settings. This is very important section. In this section, we are going to talk on baud rate and slave ID. Nowadays, we are into the digital world. So, whatever the energy is being consumed centrally or at the remote place, we have to monitor the energy on real-time basis. And for that, all the energy meters, even in household also, they are all directly connected with the GPRS controller or routers. So these routers and controllers having a specific communication protocol which talks with the any type of energy meter and fetch the data of voltage, current, energy and etc. And you can see all these data in your computer or in your mobile application. So for that, baud rate and slave ID, these are the very basic parameter which is commonly agreed by the controller manufacturer as well as the meter manufacturers, and it is mentioned in the data sheet also. So you have to correctly configure these numbers in your meters as well as in the controllers for the smooth communication. Next is CT and PT, primary and secondary. CT called current transformers and PT called primary transformers. This transformer is having their primary values and the secondary values, and this ratio defines the multiplication factor of the energy meter. So you have to correctly mention this ratio, and if you don't properly mention the ratio, your energy reading will be different and inaccurate. So precisely you have to understand that what is the my primary values of my PT transformers and what is my secondary values of my CT transformers, and based on that correct values you have to put the correct ratio in the meter. Modbus is a basic communication protocol which we talk on RS485. So this basic cabling part we will be discussing on the RS485 side. and the last topic is troubleshooting. So in totality, if you understand these basic concepts of wiring, parameter setting, operation and that troubleshooting, you are through with the all sort of metering system which is nowadays adopted in all type of industry. So now we will discuss on basic power circuit diagram. In this section we will touch a single line diagram and the schematic diagram. So now I will take you to the single line diagram, which is a very basic thing. This diagram which you are seeing on the screen, if you see there are two different sources there, power source. This is a one 415 volt 3 phase 4 wire 50 hertz incoming supply one from transformer. So this is a source 1 which we can say a grid source. Similarly there is another source called a DG source. The voltage supply of both the source are common, like this is a 3 phase 4 wire system 415 volt. Similarly DG is also having a 415 volt 3 phase 4 wire system. This two system is giving you the energy. So energy will flow from top to bottom. It will start from here, it is going to this bus. Based on your operation philosophy, this further energy will go into the different distribution and to the load. Your load could be anything, but power flow and energy flow is worldwide common, that it is going always from source to the load side. Now in this section if you see why it is a SLD, because if you see this is a common single wire we have shown here, but if you see there are four horizontal line we have strike through here. This indicates that there are a 4 wire system actually, but we are representing all these 4 wire in a single wire because it's a single line diagram. So this is the symbol for that, and with that symbol if you count there is a 4 lines 1 2 3 4. That means this is a 3 phase 4 wire system. If there is only a 3 wires, that means it is only a 3 wire system without neutral. But here we can see it's a 4 wire, that means we have a 3 phase and another one is a neutral. Here also you can read it TPN, that also clarifies that 3 phase and neutral. Same thing you can see here also. Now let us see that how the power flows and where to monitor the energy. So if you see from here, power is coming here and then it is going further down. Here if you see that we have tapped this one section, we have tapped by putting one MCB, and from there this is connected with this LMP1, which is nothing but our energy meter. So this energy meter is getting a one supply of this voltage through this MCB and it is connected here, and from there it is going to this RYB, which is an indication lamp. So with this MCB there is a two parallel connection, one to the energy meter which is a voltage sensing, and second is going to the indication lamp. Now further if you go down, this is what you see is the CT. CT is nothing but current transformer. This is a main vertical line, what you are seeing is a primary. So this is a primary and this CT is a secondary, and this CT secondary is connected to this meter also. So this meter is getting a two feed. One is from the same bus voltage feed, that is called a voltage sensing, and from the same bus there is a current sensing. So this meter has got voltage and current sensing, and based on that this meter can calculate all types of other electrical energy parameters. So let us spend 2 minutes that what are the other energy parameters and how it calculates. So I will simply tell you that one meter which we see here, and this meter is having a two sensing. This is if you see this is my meter, this is a voltage sensing, and here is a current sensing. With this, what it can calculate? One, it will show you the voltage, phase voltage and line voltage. Second, it will show you the ampere of R, Y and B. Third is, it will show you the power factor of this voltage and current. If your voltage and current are in this phase, in this case your power factor is 1. If your current is like this, in this case your power factor is lagging. So it between 1 to 0 any value will be there. And if your load is like this, then your power factor is leading. Normally we are discussing this lagging and unity power factor because in telecom our power factor is always a 1, and on other normal industries the power factor is changes between 0.7 to 0.9899. So once you give this voltage and current to this meter is having that intelligence and it will calculate the power factor also. So third parameter is the power factor. Now fourth is kilowatt. So if these 1, 2 and 3 is there, kilowatt can be calculated like one phase kilowatt is equal to one phase voltage, one phase current and power factor of particularly of that phase. So you can get the kilowatt. So this kilowatt is for the R phase, then Y phase and B phase, and then total kilowatt also you can get for all this. Then another parameter is kVA. kVA is equal to V into I. So you already have a V, already you have a I, so you can get kVA. Similarly, you can get kVAR. There is a formula called kVA square minus kW square. This is a basic Pythagoras. So you can get kVAR. This is not just a theoretical because these all parameters are there in your electricity bill also. If you are in a LT tariff consumer, you are worried only for the kilowatt and kilowatt hour. But if you are a HT consumer like data center or any big industry, then you will get a bill in a bifurcated way, like you will be getting a bill of the kilowatt, kVA and kVAR differently. And all these parameter like parameter 4, 5 and 6 has a different rate. So you should know this, what is a kilowatt, kVA and kVAR. Another parameter is, now this is the power. Now let us talk on the energy. So kilowatt into hour is equal to kWh, which is called unit. What we say unit in normal terms. Similarly kVAh. Similarly kVARH. And last is frequency. So with this V and I, you can easily calculate all these 10 parameters which your meter will be showing in the display. And based on your technology, all these parameters will be available on the remote monitoring system. So this is the basic meter which requires a voltage and current signal. If this two signal is connected properly, and if this ratio, their parameters are configured properly inside this meter, then all your parameter will be correct. Or any changes in this meter values, the ratio and configuration will disturb your all these parameters. So you should carefully enter and configure your meter in the energy management system. So what you can see now is a power circuit diagram, and in this diagram you will see the actual wiring which has been done at the site and connection also. So here you see this is a 4 lines which is called a 3 phase R, Y, B and neutral, whereas in the SLD you are seeing all this combination of R, Y, B and N as a one single line. So this is the basic difference in the single line diagram and the power circuit schematic diagram. Here this all three phase and neutral conductors is coming from the grid side, and if you see that this is going to this switch, and from there it is going to the contactor, and after that it is going to the bus bar, and from there it is distributed to the SMPS and other load. So our power flow is from top to bottom. So now if you see, this is a first tapping is been taken, tapping of the R phase, Y phase, B phase and neutral, and these all three phase and four wire are connected with this single pole, three MCBs, different MCBs are there of each pole, and neutral has been given by the neutral link, and this is connected to the this X1R, X1Y, X1B, which is nothing but the indication lamp. So this all three phase are connected with this lamp, and once this lamp glows you will come to know that there is a all these three phase are available. Now from here if you see, there is a parallel tapping has been taken, and this is neutral is going to N1, this is going to V1, voltage sensing 1, voltage sensing 2, voltage sensing 3. So this section is nothing but a voltage sensing section. If you want to see the actual meter, I will just show you. Here if you see that this is a neutral is connected to point number 1, then B 2, Y 3 and R if you see it's a 4. So 1, 2, 3 and 4 is nothing but the neutral and your R, Y, B for in the reverse order. So this is the 1, 2, 4 is for the voltage sensing. Similarly if you see in the drawing, this is the your meter. What we see there, this is your meter which we call load manager make LNT Vega meter. So now we understood that 1, 2, 3 and 4. Similarly voltage sensing is over. Now current sensing, there are 3 phase and 3 different CT for the each phase. So this is a phase 1 CT. Every CT is having a 2 terminal S1 and S2, S1 and S2, S1 and S2. All these S2 terminals are common together and they are earth. And all these S1 terminals of every CT is connected here S1, S2, S1, S2, S1, S2. So you see that there are 6 terminals for this 3 phase, because every phase is having at 1 CT and 1 CT is having a 2 terminals. So 3 into 2, 6 is connected to this side of the meter, which is nothing but the current sensing. Now let us see in the actual diagram. If you see that this is a CT1 of R which is connected to 11 and 12, then CTY which is connected to 13 and 14, and CTB which is connected to 15 and 16. So 11 to 16 is your current sensing, whereas your 1 to 4 is your voltage sensing. This is the very important parameter and very important connection which you have to properly check by checking the potential here and measuring the current also here at this, and you have to tighten this also properly. If it is loose, then you may not get proper voltage or proper current, and that's why there is a chance that your reading is lesser or incorrect. So this you have to ensure during every preventive maintenance also. Now let us come back to this diagram. So this is the basic power wiring diagram. This is a voltage sensing and this is a current sensing. Anytime if you want to work on this meter, you have to switch off this MCB phase wise. So at least this meter will not have any sort of potential and you can freely work on this. Similarly, if you see here, this is a one terminal has been given which is called a city shorting link. This link also I will show you in the picture. This link is normally in a short condition. Whenever any panel is supplied by the manufacturer, this meter is not live, so he always ensure that this terminal is shorted by this link. So at the you install and commission the panel, that time this link has to open, otherwise your current will not go in this meter and your meter will show as zero current. And if your current is zero, all your parameter is zero, because kVA, kVAR and kW, these are the basic three power parameter, which is a multiplication of voltage and current. So if current is zero, everything will be zero. So you have to ensure that this CT terminal and CT link, shorting link, should always in a open condition. Whenever you want to replace this meter for any reason, that time when you disconnect this meter, always you remove this power connection V1, V2 and V3, and always put a insulation tab properly, so it should not get shock or it should not touch any body also. At the same time, you keep this MCB also in a switch off condition, so by mistake also power should not reach at this terminal. So similarly, same precaution you have to ensure in the CT side also, but in the voltage side, difference is that there is a voltage, where in the CT side there is a no voltage, it is a zero potential, because it is always shorted. Either it is shorted here or it is shorted inside the meter. But for the metering purpose, this CT has to be shorted inside the meter. There is a current measuring coil, so this CT has to connected with that, and this link has to be open. But for any reason, if you are replacing the meter, that time you have to remove this S1 and S2 of phase R, S1 and S2 of phase Y, S1 and S2 of phase B, and you have to properly insulate this, and after that immediately you have to short this. Before removing the meter, you have to, first of all, you have to short this, so at least there is a no chance of any potential development, and after that you can smoothly remove S1, S2, and then you can put a insulation tape on this. So that is how you have to always change the meter for any type of requirement. If this meter is faulty and if you want to change, this is the procedure you have to follow, and in this CT shorting is very important. So I will just take you to the photographs where you will see that how the CT shorting terminal looks like. So this is the photo which is a CT shorting terminal which is installed in our LT panel. So one side, this section is coming from the CT side, where CT is inserted in the primary cable, and this is the other side where this secondary is going to the LT meter. So this is orange color, what you are seeing is the shorting terminal. You have to just open this screw with the screwdriver and you have to insert on top side. It is like a stopper. So if it is here, it is open, so your current will come from here and it will go to your LT meter. But if you make it on the upper side, that means it is shorted and your current will not flow. It will be directly flowing through this shorting link and back to the S1 to S2. So this is the basic CT shorting terminal. And if you look at on either side, I think there is a open and close also, that marking is also given. So that way you can understand that if your meter is anyway showing the value of current, that means you understand that this is a open position. So whenever you want to remove your meter, just change the direction on the opposite side and then you can remove your meter. And after installing the new meter, you have to make this CT in as it is condition, this CT shorting terminal, so you can get your correct value of the ampere. So this is the basic of CT shorting. So in this section we discuss about the this wiring connection of this meter. We have seen the actual photographs and the terminations, how the voltage sensing is connected and how the current sensing is connected. Now in the next section we will discuss about the basic parameter settings. Before we go to the next session, if you see here, this is a 9 and 10. This is a very important parameter which is for the RS485 communication. So if you look at in the picture, I think I will take you to this picture also again. So you will see that in this also, if you see this 9 and 10 is your communication supply, So every meter is having this 9 and 10. There's a grid meter, there is a 9 and 10, and from there this J101 and 102, this two terminal is coming out, which is we can see red and black. Similarly in the DG section also same terminal is coming out, and they are connected in parallel, red to red and black to black, and from there it is becoming common and it is going to the SMPS. I will discuss that diagram also from LT panel to the SMPS connection. So this is a very important thing. If you have to ensure that this connection is properly tightened and you can get some potential also at this terminal. To check the healthiness of the RS485 port, what you can do, you can put your multimeter in the DC range, and you can see, try to select the lowest range possible. Like you will not get voltage more than 5 volt here, so try to put your voltage range accordingly in the DC and just measure the voltage what is coming here. After that you can remove these positive and negative J101 and J102, and then again you can measure the voltage just across these two terminal. So you will come to know that this meter is generating how much of DC potential at this terminal, and based on that we can decide that RS485 port is healthy or faulty. So this is also very much required. If you look at the this energy meter OEM manual, they have mentioned that this voltage value can be between 0.5 to 5 volt or so, but there is no specific values they have mentioned. They have just mentioned the range. So we have to check this value with the connection and without connection in EV meter as well as in the DG meter. So by just comparison also we'll come to know that which meter RS485 port is healthy and which meter RS485 is faulty. Because sometimes it happens that some meter is showing correctly in their display, but after having a proper connection also you are not getting value in your portal. So that time you have to check all the connection properly, because there could be a reason that this connection is loose, or there could be a reason that this port itself is a faulty. If port is faulty, you cannot do anything here, you have to replace the entire meter. So now let us go to the parameter setting section, in which we will discuss about the parameter values. So now we are into the section of parameter settings, which is very important section, because whatever the problems we find out in the visibility at the server side, we always see that there is an issue in the configuration, or we can say in the parameter settings, and because of that either we are getting zero values or we are getting some negative readings, or sometimes if configuration itself is not there, in that case we just get dash value. That means there is no value is coming in the kWh or in the diesel side, fuel stock, run hours, and we cannot measure anything on that. We do not know whether this site is having a grid consumption of how much of kilowatt, or whether DG is running, or what is the fuel stock and all this. So nothing works if your configuration is not proper. So I request that kindly give a full concentration on this. Whatever I am going to show you here, this all supporting documents I have already given you, and in every mails is already attached there. So I am just going to open only the required portion of the documents. So whenever you are free, you have to open that documents, and whenever you are going to the site for any rectification, you have to refer that particular section, and you have to ensure at the site. So I think your troubleshooting also partially will be covered in this section. So now let us go to this directly, the document. This document we have already send you this commissioning guideline for the integrating the energy meter with the SMPS controller. So in this guideline, this is the index in which you have to see that section number 4, 5 and 6 enabling the AC energy meter in the SMPS controller. So you have to configure the our Vega make energy meter or whatever make energy meter and with the SMPS controller. So both the sides you have to put the correct values. Section 5 is talking about the baud rate and device IDs, and then the what the final programming is required or not. That's so basically section 4 and 5 is a important section for any kind of SMPS. So that we will discuss step by step here. So now section 4 we have seen in the screen, in which section 4.1 is saying that if you have a immersion or Vertu make SMPS install at your site and your version is M523S, in that case in the SMPS site you have to go into the main menu, then you have to select the settings, communication settings, and there is a one parameter called external AC energy meter, external ACEM. This parameter you will see on, and that parameter you have to select enable. So if it is a disable, you have to change from disable to enable. Once you do this in the immersion make SMPS, your setting for measuring the DG and EB energy is completed. This is a very simple setting in this immersion make, because it doesn't require any other steps to follow. Simply you have to do the external ACEM enable, and that's it for the Vega meter reflection. So this is the settings you have to do in the SMPS controller. Now if you have a G make SMPS, in that case you have to see only 4.2. Now G make is having little difference, but it is not that difficult. So I will tell you one by one that we have to configure a DG meter in the G SMPS, as well as we have to configure EB meter also in the same SMPS. So there is a common procedures for both the things, only ID will change. So let us now discuss that for the SEB meter you have to open a main menu, then you have to open a configuration, system settings, and in the system settings you will find Modbus device. This parameter will appear, and there will be a mode 1 to mode 8, different mode will come, mode 1, mode 2, mode 3, mode 4, likewise mode 8 will come. So now you have to select in mode 7 to enable your EB meter. So once you select the mode 7 and then check the status of device whether it is enable or disable. If your mode 7 is disable, then you have to convert this setting into the enable first of all. So if it is found disable, then configure this parameter in the below sequence. If you found this mode 7 is disable, then you have to see the parameter in this below sequence 4, 3 and 2 and 1. In this sequence you have to set in the your G SMPS controller. So let's say I open this main menu, then configuration, and finally I went to mode 7 and I found that my mode 7 is disable. Then I have to follow this 4, 3, 2, 1. If my mode 7 is enable, you don't need to do anything. So in mode 7, let's say is a disable, so I went serial number 4 device, which I have to select enable ENA, then slave ID, which is a 20 because I am configuring EB meter, then description RM is ACEM1, that you have to select, and then next is you have to select type MBRM1. So this 4, 3 and 2, 1, whatever is we have mentioned here, that you have to select in the controller. Once you do this, your EB section configuration in the SMPS controller is completed. Now let us go for the DG meter configuration. Similarly, DG meter also you have to select menu, configuration, settings, Modbus, and here you have to select mode 8. Mode 8 is for the DG. If it is found disable, then you have to select this serial number 4, again device enable. Now slave ID is here different, it is 21 because it is a DG meter. Description, you have to select RMACM 2, and in type you have to select MBRM1. So mode 7 and mode 8, now you are done. That means your EB and DG part is completed in the GSMPS and in the immersion SMPS. Both the SMPS we have discussed separately. Now let us see that what is next in this. So SMPS part is over. Now you have to open your Vega meter. So Vega meter is also having a different procedures to, because it both the device are different, both has a different password. So you have to have a password for them. So I will discuss what the password and how to open. But just to understand in a short, if you are a immersion SMPS, then in the Vega meter you have to select baud rate 9600, and your device ID for SCB is 20 and your for DG is 21. For the, if you are having a G control, G SMPS, in that case in the Vega meter you have to select 19200 baud rate. Your device ID will be 20 for EB meter, and for the DG meter your device ID is 21. So this is what you have to select there, and now this document is over. So now we will go to the Vega meter manual, that how to open the Vega meter and how to put this value, this baud rate and this slave ID which we have discussed initially. After that we will discuss how to put the CT ratio and PT ratio also there. So these 4 parameters now we will learn in the Vega meter. So we'll go there now. So let me just open that page for you, which is a Vega meter. So this is the Vega meter manual. This manual also I have shared all of you with all of you. Here you have to only see the section 2.3. If you read this section 2.3, let me just make big for you. So this section is giving you the idea that how to enter into the Vega meter and how to change the values, how to save the values. This is all about for serial number 1 to this 12 or 13 is there. So that you have to follow, right? So there is nothing much to discuss, because you have to open this page and you have to put this up arrow and down key what you have mentioned here, and then you have to put up this password which is 0000. Once you entered this password correctly, you will enter in this, and after that you can select the page for every parameter. Like we want to select slave ID, then we want to select CT primary, CT secondary, PT primary, PT secondary. So these all 4 pages you have to select one by one, and you have to change the values as per your requirement. So this is the one section 2.3 where you have to see how to operate the Vega meter. Now what are the values are there, that already I told you that our values, we know that what values we have to mention there. Let us understand again here. Like once you go into the slave ID, I told you that our slave ID for the EB side is 20 and DG side is 21. So here we have to open a slave ID. If you are opening the EB meter, you have to select a 20 here. If you are configuring your DG meter, you have to select 21 here. That is one. When you open this, you will see this number SLID. This is what the display will come, and there you have to put your value. By default there is a one setting is given by the factory, which you have to replace by the 20 or 21 as per the requirement. I will just show you the pictures of the actual meter, so at least you will come to know that how it shows. So now you can see on the screen that this is the display you will get, which is saying slave ID SLID, and I have selected a 0020 because it's a EB incomer. If you see here, so I have selected 20 as my slave ID. So if you see there in your this, you will see like SLID. The same I am showing you here, it is showing like this. So once your parameter 1 is completed, then you have to select the baud rate. So baud rate also will come, I will show you that. Like I have mentioned the baud rate on the panel itself. So this is the baud rate you see. Here baud rate we have selected 1.19.20, which is equivalent to 19,200, right? So this is the value you have to select, 19,200. If you are having this different SMPS is having a different baud rate. So let us open that document, so we should not get confused for the baud rate, because baud rate is also a very important part. If you are having a immersion SMPS, your baud rate is 9600, which is 9.6, you will see there. And if you have a GSMPS, your baud rate should be 19,200, so it will be equivalent to 19.20. So this is what you can see in that section, right? So now let us proceed for this further. So this is my baud rate. So now this baud rate is also over. Now next what we are going to see is the CT setting, CT primary and CT secondary, serial number 3 and 4, and PT primary and PT secondary, serial number 5 and 6. So in short, you have to select, you have to configure this serial number 1 to 6 correctly, and I think you are done. So let us see what is my CT secondary. So as I mentioned in you in the mail also, and I will just uh, make some diagram just to make you easily understood that what is my CT secondary and CT primary. So if you see, I am just showing one phase, and this is my CT. Now this CT could be 200 by 1 or it could be 400 by 1. I have told you that your panel type A, B and D, your CT will be 400 by 1, and in your panel C, your CT will be 200 by 1. But this is, there could be some mistake also. So before configuring this, you have to see your panel. When you open your panel, you see that there is a make is mentioned, like it's a Bharat make or Interlake make, that is one, in which you see that there is a MCCB section and power contactor also, right? If your MCCB and your power contactor is 200 ampere rated, then your CT you have to select 200 ampere by 1. And if you have a bigger size of power panel where your MCCB incomer is 400 ampere rated and your power contactor is MCX43, then you have to select 400 by 1 as a CT primary, and this is CT secondary. So I am giving you always in the mail also, and also this CT also you can see in the panel, but you have to use your mobile torch to read the nameplate of the CT, because it is always connected on the back side. So I think from whatever the access is there, you can try to look at that, and you will come to know that what the CT is. In some drawing it is mentioned, in some drawing it is mentioned in the BOQ. Sorry. So that's how you have to configure that. You have to understood that what value you have to select for the CT. So now CT primary, CT primary is done, which is either 200 or 400. CT secondary is always same for any type of panel, this is 1. Similarly, PT primary is always 415 and PT secondary is always 415 for all types of panel. So I think now you are very much clear that what is the value we have to select for the parameters. So I have told you the setting inside the SMPS for the immersion or vertive and G. Immersion is very simple. In G you have to select mode 7 for the grid and mode 8 for the DG set. Once you complete your setting in the SMPS, you have to come to the LT panel in which your energy meter you have to enter your password, and you have to select your slave ID, your baud rate, and then your PT primary and your PT secondary. Just for sake of simplicity, I will just show you some photographs, so at least you will come to know that what exactly we are looking at from you. So I will just show you quickly a few pictures which I have taken from the panel. Like this is the PT primary. So you see that PT primary, it is 415 volt. Similarly PT secondary also should be 415 volt. Here the CT primary is 400 ampere because it's a bigger panel, so it's a 400 ampere. Here the CT primary is a different panel, so here CT primary we have selected is a 200 ampere, right? Here the CT secondary CTSE is a 1, which is common in all the panels. So now you know that what is a CT primary, secondary, and PT primary and PT secondary. Once you do all this wiring and all the parameter settings, and if everything is okay, your communication port is working fine, in that condition you will get the values in your SMPS controller first of all, and after that you will get the values in your remote monitoring system. So first check your connection, do the right settings, parameter and configuration, and after that you have to hard reset the SMPS controller once. Once you do the hard reset, and after that if your communication fail alarm is disappearing, that means your communication is okay. Let's say you have completed your EB section thoroughly and your site is running on the EB power, and after hard resetting, if your ACEM1 communication fail alarm is disappeared, that means your EB data is reached to your SMPS controller. So one part is over, and now from there it should reach to the router, and from router it will reach to the your remote monitoring portal. But DG is switch off condition, so even if you completed everything for the DG, as DG power is off, DG meter is off, so you will not get DG data. So you will get an alarm that ACEM2, AC energy meter 2 communication fail. So that is okay. That you can verify by switching off the EB and switch on the DG, take the site on DG, and then similarly you can verify that meter also. So likewise you have to ensure that both the meters are displaying the correct values, as well as your configuration and all the parameters what you are looking like kWh, that should come into your SMPS, as well as it will appear in your portal also. So this is the basic thing of this overall AC energy meter training. Now we will discuss on the basic troubleshooting part. So before we proceed to the troubleshooting, just one thing I want to show you as a one common diagram. There's this is the backside of these two meters. This RS485 of these, both the meters are in parallel condition. If you see that this positive and negative both are combined together, and in just above block diagram we will come to know that this is a DG meter and this is a AB meter. Both RS485 are common, and it is going to the terminal number 13A, which is a positive, and 14B, which is a negative. This terminal is mounted in your LT panel. Also DG side also it is the same thing. DG controller is fitted inside the DG. There is a 49 and 51 in the DEF controller, which is also RS485. From there also positive and negative is coming, and this positive and negative in some side it is directly going to the SMPS, or in some side it is coming to this meter. And all these three pair, one pair from the DG, one pair from the EB meter, and one pair from the DG energy meter, all these three pairs are combined together here, and from there it is going to the SMPS. Now there is a different terminal in different make of SMPS. So I will just show you, like this is a photo of the immersion SMPS, in which there is a this terminal has been given, that is 31 and 32, 33 and 34, 35 and 36. So one terminal is exclusively for the BMS. Like you have a battery section is there. So from battery, that RS485 is coming here, which is terminating here at 31 and 32. 33 and 34 is for your DG and EB meter from the LT panel, and another section is for your DG, directly it is coming from your AMF panel, and you will get all the data from here. It is connected here, and from there it goes to controller, and you will get all the data there if all this connection is proper. I will just show you some other pictures also. Like if you see that if you open your SMPS door, you will find this terminal details there. If you see, this is same Vertu make or immersion make SMPS, in which 31 and 32, this is for RS485 for the battery management system BMS. This 33 and 34 is for the RS485 for the GCU oblique ACEM. Similarly at 35 and 36, RS485 for GCU and ACEM. So either you can combine all 3 meters together here, or you can, if you are brought your DG connection directly here, then your EB meter and your DG meter you can connect here. So it depends, but finally all are in parallel condition, and from there it is going to the final controller. So in SMPS side also you have to correctly connect the cables, and you have to ensure that this termination is properly tight and it is not loose. If required, you can reconnect it, so at least there is a double check that there is nothing loose, and after that only, if nothing comes, then only we should troubleshoot. So this is the basic thing what we learned today. Now we'll just take a couple of minutes for the DG side also, because the same way we have to configure the DG controller also. So once you configure the DG controller, you will get the DG data also in the SMPS. So for the energy meter, you configured energy meter as well as SMPS controller. Similarly for the diesel generator, you have to configure the diesel generator controller and the SMPS both. Once you configure both the sides, you will start getting the data for DG directly. So you will get DG runover as well as the fuel level. So now let us spend 5 minutes for the DG controller configuration. So this is a guideline which we have given you, that commissioning for DG, guideline for integrating DG controllers with the SMPS controller. So now let us quickly move that what we are supposed to see here, that there are two kind of controllers, because we have two different DG sets. One is a Mahindra and Mahindra, and other one is a Supernova. Mahindra is using Dipsy controller, whereas Supernova is using DEF controller. So we will be seeing what is the difference and what the things. This is a DEF controller, where on the back side you see this 49 and 51 is your positive and negative, and from there this wire goes to the terminal, and from terminal it is directly going to the either to LT panel or to the SMPS. If it is a Dipsy controller, then your connector is connecting here. You see that it exclusively the port is given. By seeing the port also, you can see that this is RS485 connector. So you have to just simply match the drawing, and after that this is a diagram which shows that your DG cable has gone to LT panel, and from LT panel both the energy meter as well as the DG, all three becomes common, and it is terminated here, and from there it is going to the SMPS. So this diagram already we have discussed. Now let us quickly go through this, what we have to do in the immersion SMPS. So same in the immersion SMPS, you have to go to the menu, settings, communication settings, and in that you will get GCU, and in the GCU you will get two options, DEF or deep C. So whatever your controller is there, that you have to select. If I am having a DEF controller, I will select DEF. If I am having a deep C controller, I will select this deep C. And once you enter the password, you can configure this, and finally you have to save this setting and you have to come out. Like this is a GCU, this GCU is disabled, so you have to make it enable first of all. Once you change it, you will see the name of the controller here, DEF. So you have to select this, you have to enable it, and it is done. So this is a very simple procedure for the immersion or Virtue Make SMPS. Now if you have a G Make SMPS, you have to see that your version at least should be 0.15D, and after that you have to go into this menu, configuration, power plant related settings, then GCU type. There you have to select like DEF or deep C based on actual DG install. These are the photographs. It's not much visible, but when you open your controller, SMPS controller, you will see the same photographs there. Then again here we will be seeing that mode 23 we have to select for the DG set. If you remember, we have selected in the GSMPS mode 7 for the EB energy meter and mode 8 for the DG energy meter. Now we are configuring the DG set controller, in which we are going to see the DG runover and the fuel level, and for that we have to select mode 23. And if your mode 23 is disabled, then you have to select the sequence 4321 as mentioned. Device, it should be enabled. Then slave ID, you have to select 9 for the DEF and 10 for the deep C. Serial number 2 is DES. We have to select RM, DS, DG, that you have to select. And serial number 1 type, there you have to select MB RM-1. Once you complete this, your setting is completed in the SMPS. Now you have to go to your DG controller, which is installed inside the DG panel. There you have to select, if it is for the DEF, you have to just go into this, you have to click on this OK, and your GCU home screen will appear like this. Then you select this arrow as shown here, and once you click OK, you will go inside further. After that, you have to select this channel number 75000, which is a communication channel. Once you select this 75000, then once you click on this, you will get another channel 7510, where it is mentioned external communication ID. Once you select and click OK, then you will get this address, in which you have to enter OK, put the password. It will ask the password, mention your password as shown above, and then you have to select this address value 9. Once you select this 9, then only this controller will start communicating data to your SMPS controller. So this address should be 9, and then once it is there, you have to go back by pushing this back button, and you are done. So you have to select your configuration you have to do in your DG controller as well as in the SMPS controller for the DG data. Similarly, for the deep C also, this detail has been given that you have to follow. Though we do not have much DG set for the Mahindra, but still wherever the Mahindra make DG set is there, you have to ensure this baud rate as well as the your settings. So this is what the overall configuration settings for the both the energy meter which is installed in the LT panel, as well as both the DG controller which is installed in the DG set. So I think almost we have covered all the topics. Now basic troubleshooting we will see, and then we will end this training session. So now let's say we have checked the all our configuration and all, but we are not able to get the reading on our SMPS controller. So first of all, we have to ensure that my RS485 connection is okay or not. So as I told you, you have to remove this. You measure the voltage here and just see that whether voltage is coming or it is not coming. There is no exact value, but there should be at least 0.9 volt should come here. And if it is there, then we can assume that this meter is working. Same thing you have to check on the DG, and by comparison method you have to make out that what is right, what is wrong. After that, if still data is not coming, just for a sake of 1 minute, what you have to do, you have to interchange this connection, negative to positive and positive to negative. You have to reverse this connection here and just see that whether any changes or not. After changing this, try to hard reset the SMPS controller once, and if see that if anything is coming there, I think then you have fixed the problem. But if it is not coming, just come here again and put your connection as it is. Don't keep this connection permanent. Just for the cross checking, you have to do this method. So this is the one troubleshooting which you need to complete if data is not coming. But every time you have to ensure that you have to hard reset the SMPS controller by doing any changes here, so that changes get implemented there. If your problem is not solved even by doing that again you have to ensure that your baud rate and your slave IDs in both the places are okay. Number one. Number two is your other parameter also you have to ensure, and at the same time SMPS also, whatever the settings we have discussed, that you have to see that it is saved properly. It should not be that you have changed, but once you without saving, if you exit, then you will not get all these parameters there. So you have to ensure that both the side parameters are changed and it is saved. After that, even if you are not getting the values, then you have to make sure that any 1 meter is correct. Out of, like, if EB is not running properly and if your DG meter is let's say it is healthy, and whenever DG runs it shows the value, and that reading is available in Everest, in that case you have to swap this meter with the EB and DG, because normally at every AG2 side our EB availability is around 21 hours 22 hours. So mostly EB meter runs, so there is a problem in EB meter is more because it is running more, whereas DG meter is always idle almost 20 hours a day. So that DG meter is normally we found based on experience that it is always healthy. So that meter you have to swap here, and you have to again change the slave ID, because it now if it is a EB meter you have to change the EB ID, which is slave ID is 20, and this meter is going there in the DG side, so this ID has to change from 20 to 21. So this is the one method you have to ensure that after doing that, if you are getting EB values, because our importance is that we want to get the EB values, EB energy, because maximum energy is consuming by the EB side. For example, if we are consuming 100 units a day in total, out of this 195% of power is coming from the grid and 5% is coming from the DG. So our interest is to ensure that our EB part is healthy and we can monitor that value. Then only we can make out what is the energy efficiencies on our site, because DG is having a very limited role in these critical sites. So that's why we are very much interested in making the EB side healthy. So you have to put a same approach, and you have to ensure that your EB section should remain healthy, and that is how you have to make your troubleshoot. Even after doing all this, if still your data is not showing in the SMPS, and AC communication fail alarm also available there in SMPS, then one more try you can do, that you can bring one small cable and you directly connect here, remove these two cables, put your new cable and run on the surface, and straight you can take to the SMPS, and you connect your this cable in your 31 and 32 or 33 and 34, or 35 and 36 in the Vertu or immersion make SMPS. So if there is any chance in the breakage or continuity of this RS485 cable, then that doubt also will be clear. And if after doing that, if you are getting the value there, then that means there is your cable is having some fault. So you have to find out the faulty cable by checking the continuity, and you have to remove that part. So this is also a one basic troubleshooting. Sometimes it works because these all the cables are 5 to 6 years old, and there is a chance that some strands are broken, and because of that signal is very weak and you are not getting the value there. So this is the basic troubleshooting which is possible in the L&T make Vega meter or any other make Vega meter, as well as same way you have to see in the controller of the DG also, because there is also a voltage sensing, current sensing, and also there is a RS485 communication. So same thing you have to try there, and I think if you try all these, 95% there is a success ratio that your meter will become healthy and it will start communicating. Wherever there is a issue, like few meters are in the gigawatt hour range, so in that case it always moves every 10,000 megawatt hours. So let's say if you have a, for example, if your energy meter is 68.1 gigawatt hour on the meter display, so in the Everest you will see only 68 gigahertz. 68 into 10 raised to 6, you will get that this is what the kWh there, but that kWh will remain same on every day 1, day 2, day 3, day 4, because meter is moving, but it will take the value at every 10,000 unit get consumed, then only that value will change in the Everest. So for example, it is 68.1, in Everest it will show 68.0. On the next day in the Vega meter it is showing 68.2, but in the on the remote monitoring you will see only 68.0. So till it becomes 68.9, and then when it becomes 70 or 69, then only you will get the reading 69. After that again it becomes 69.1, 69.2, 69.4, 5, 6, 7, 8, 9, and then it becomes 70. So when it crosses 69, then you will get the reading. When it crosses 70, then also you will get the reading. In between you will not get the reading. So this is a limitation of this, because once the scale is reaching in the gigawatt hour, your reading will only appear at some random interval called 15 days or maybe 30 days whenever your energy is consumed. So that is also one reason, so in which you cannot do anything, because this meter we do not know how to reset the counter of the kWh. So there we need to replace the meter with the appropriate make and appropriate as per the engineering guideline. So that guideline will provide you, but till the time you have to ensure that all this guideline is in place. We have given you the drawings, we have given you the procedures, and or with the photographs and also all this, and it is there in every mail. So you have to ensure that this should be as per that. And I request all our team members and our partners also, they have to go through with this training modules, and accordingly they have to go to the site and they have to try to match the things. So they can be also get acquainted with the system, and they can also have a good confidence on the energy metering part. So in nutshell, if you know this basic thing of energy metering, then you can easily figure out that what could be the issue, how to tweak the meter. People are doing stealing, they are changing the ratios, multiplication factor. So you can also all this figure out if you know the all nitty gritty of this metering system. So I hope that you like this module. I try to cover all this topic as much as possible, and in our next module we will discuss in detail about the technical parameters of all energy, all our control and power winding diagrams, and especially the troubleshooting and the critical alarms which is coming in the DG, and how to resolve that alarm, how to find out the faults, and how to reset the faults. All these things we will discuss in detail in our next training session. I request that you kindly subscribe this and share with your friends and your team members, and ensure that they watch it thoroughly. Then only you can take a maximum benefit of this. Thank you for now.